Question 8, part A, we've got a simple quadratic to solve. So a quadratic is anything that's got x squared as its highest power. So this quadratic is 2x squared equals 72. Now it might be that you can do this by trial and error, but an algebraic solution is going to be a little bit more efficient. So I'm going to start with 2x squared equals 72, and then think about how I need to undo everything I've done to get a value for x. Well, first of all, I've got 2x squared. If I want to get down to just 1x squared, if I divide both sides of that equation by 2, I'm going to get 72 divided by 2, 36. So x squared is 36, so something squared gives us 36. So to undo squaring, I'm going to need to square root. The square root of 36, normally we say it's 6. So x equals 6 would be a perfectly fine answer for this. You'll notice the question says a value of x. It would also be perfectly okay to write down x equals minus 6 as the answer to this, because when we square root, we've actually got two values we could use. We could use the positive square root, so square root of 36 is 6, but also remember, if I square minus 6, that's the same as minus 6 times minus 6. Negative times negative gives me a positive. So minus 6 squared is also 36. So the square root of 36 could be 6, or it could be minus 6. Either of those answers would be correct. And then part B, we are writing 72 as a product. Product means multiply together, of prime factors. So prime numbers are numbers that have two factors only. So there's only one way of making them by multiplying. So there's only one way to make 2 by multiplying, that's a prime number. Only one way to make 3 by multiplying, that's a prime number. 4 is 4 times 1 and 2 times 2, so 4 isn't a prime number. Really, you should try and learn your early prime numbers, so the small numbers. You've got 2, 3, 5, 7. 9 isn't a prime number because it can be made as 3 times 3, so your next one's 11, and so on. So what we're doing is splitting this into prime factors, so numbers, prime numbers that can multiply to give us 72. There's actually a little clue in the first bit of the question, because we know if 2x squared is 72, then 2 will go into it, and 2 times 36 makes 72. So if you circle your prime numbers, it makes things easier later on. So 2 is a prime number, can't split that any further, but 36 isn't prime, we can split that up. It's better if you do them in order, so first of all I'm going to check if 2 goes into 36. Well, it does. Half of 36 is 18, so again 2 is a prime number, but 18 isn't, so I can split 18 further. Well, 2 will go into 18. 2 times 9 makes 18. 9's not a prime number. Now 2 won't go into 9, so I'm going to check my next prime number, 3. Well, 3 will go into 9, it's 3 times 3. And once I've got prime numbers on the end of each one of these branches now, I've then split it into a product of prime factors. So I then need to write out that 72 is 2 times 2 times 2 times 3 times 3. Sometimes a question might ask for this in index form. It doesn't actually say it here. If it did, it would probably be an extra mark on the question. If it did say in index form, you'd then just simplify 2 times 2 times 2 as 2 cubed. Remember that cubed means that we've got 3 2's multiplied together, times 3, 2 3's, 3 squared. If you wrote that, you'd still get both marks for the question, but you don't actually need to do that here to get both your marks and get the answer completely correct.